what we're looking at today is angles. So what we're starting today are angles. Now this here is a what? Protractor. A compass is a device that we can copy angles with, but this here is a protractor. A protractor, that's a different compass. Yep, two different kinds of compasses. All right, so we use this to measure I'll take one today, a angle. Now, if you notice, there are two tracks on this compass. On the left side, there's one that starts at 0 and another that starts at 180. On the right side, there's one that starts at 0 and the other that starts at 180. Now, the one on the right, the one on the inside starts at 0 and comes over here to the inside on the left is at 180. So it's going from 0 to 180. Now, the other is the opposite. So on the left side, it starts at 0 and it goes over to 180. This gives us the ability to line it up no matter which side or which way the angle opens to be able to measure it from 0. We have two different ways we can use it. Now, let's go and look at these here. Well, an angle is a set of points consisting of two rays, two different rays. So two rays make an angle. So for any angle, it's consisted of two rays or two line segments. The vertex is the endpoint of the two rays, and the sides are the two rays. Now, there are three different ways, you're welcome, that we can name an angle. We'll look at those here in a second. Whenever we're naming an angle, we're going to need this little angle marker. It's going to signify that it is an angle. Just like when we were naming lines, how we did the line segment or line above it or ray above the lettering. We're going to do a similar thing here, except it's going to be a little angle is going to go out front. Angle. So let's look at naming an angle. Now, the first way that we can name an angle is based off its vertex. So the vertex for this here would be letter A. So I can call this angle angle A based off its vertex. Now, we won't always be able to use the vertex to name an angle. If there are more than one angles at that vertex that share a common vertex, we cannot use it. And we'll look at an example coming up where I can point that out to you. Once we see it, it'll make sense. Now, the other way that we can name it is based off a number. Because if you notice this here, they have the number 1 inside the angle between the two rays. We can use it to name the angle. So I can call this angle 1. Bless you. Now, the other way is using the points. And the vertex will always be in the center. So we do have a point C, vertex A, and point B. Now, if you remember when we talked about naming polygons, this may seem very similar because on a polygon we picked a point and then went around, yes? So this is kind of similar because we picked a point C. We can't pick the vertex. C went to the vertex A and then came over to B. We traced the angle. Or what other way could we name this? Angle. Because A is the vertex. We can't start in the middle. So when we use the three letters, we're almost tracing the angle out. So CAB or BAC. So we don't use vertex. Japanese, it's the name of the high school. It's a show. Haiku. Any other questions on this here before we move on? Okay. Next one we have is the interior and exterior of an angle. Well, interior of the angle are all points between the sides of the angle. It's all the stuff, what? Inside the angle. Exterior of the angle, all the points? Outside. Exterior is going to be the outside. Interior is the inside. And we really consider it to be the inside of the angle if it's less than 180 degrees straight line. Yeah. We good to move on? Yes? Okay. Let's look at this first example of naming angles. A lighthouse keeper measures the angles formed by the lighthouse at point M in 3 boats. Name 3 angles in the diagram. So this here, there we go. Start out with this here. So this here would be one of the rays that make up an angle, yes? Let's pick another color. Let's say yellow. This here and green. Now, if I said angle M, which 2 colors would be making up that angle? Well, it could be green and yellow. It could be yellow and green. It could be red and green. Any of those could make up the angle, yes? But whenever we're naming it, we want it to name a specific one, yes? Because we don't like it if it names multiple things at once. It's hard to tell. This here is what I was mentioning earlier, where we cannot use the vertex to name the angle because there is 3 different angles or multiple different angles here. So this is the case where we can't use the vertex to name it. Now, they didn't give us numbers but inside of the angle, so we can't use that. So we're stuck with using the 3 letters. So let's look at this here. What is one set of 3 letters we can use to name this angle? L, M, J, yes. Another one.
L, M, K.
Mm-hmm.
J, M, L.
K, M, L.
L, K, J.
J,
What?
M, K.
Can't do 4.
L. So L is all out.
J, M, K. K, J, L.
K, M. So K, M, L. So let's look at this. So L, M, J, L, M, K. K, M, L. And we could have angle K, M, J. And that's it. Because there should each endpoint, L will have 2 that we can use with it being first. K, we can have 2 with it being first, and J, we can have 2 because there's 2 main angles. J, M, K, J, M, L. So there's 6 total that we could use. It only really asks for 3, but we went on and named all 6. Any questions on this here? Yeah. Yes, sir. So let's look at number 1 here. What is one way that we can name this?
PQR.
Yes, so we could say PQR. We could say Q.
RPQ. Or RPP.
RQP.
Is there any other way that we can name it?
XYZ.
No.
Q has to be in the middle.
Wait, why is it just Q hard?
Because Q is the what? Vertex. Vertex. Now, since there's only one angle, because there's only one, well, there's two, but there's only one main angle that we have here, we can name it by its vertex. Now, because from here to here would be the main angle. Now, we could technically say that this here is another angle, but we do not reference it. We mainly reference the one that is less than 180. Because even if we did hit, the 180 is a straight line and we'll get there. If we hit something above 180, well, going this direction, going above it, would be more than 180, yes?
Yes.
But if I go underneath it is now less. Because 180, if I go in either direction, one of them will be less than 180. And that's the main one we focus on. Yes, sir.
So when it is like that, was it called like an acute angle?
Possibly. Yep, and we will get there in a second. Let's look at number 2. X, Y, Z.
Y.
Y,
Y.
Z, Y, X.
Who am I to think of this?
1.
What? Oh.
Since this one here, they threw 1 in the middle of the angle, we can use it. Yeah, they put a 1 inside of it, so we can use it to name it. Just like with the next one here, since there's a 2 inside, we can say 2. FED, and angle E. Any of these here can be used to name that angle. But if we have more than one, we have to stick to 3 letters. Questions on these here? Okay. I'm going to show this here. I don't think that we'll need to, there's going to be a lot of words with this, so let's actually look at it before you start writing anything down. Consider OB and point A on the side of OB. So what that's saying is consider a line. And then we have a point on one side of that line. So that's it. So we have a line here. And then we have a point up here. The ray OA, okay, can be matched to 1 to 1 with a real number between 0 and 180. So on the protractor, we can put a number to it where it's at compared to the line. Then the measure of AOB, the measure of this angle, is equal to be written as the measure. So we'll put a little m to talk about the measure of the angle. Measure of angle AOB is equal to the absolute value of the difference between the real numbers. Well, here, this is at 0, yes?
Yes.
And if we look at this here going this direction, so it's increasing, 0 all the way up to 140, well, we can say that its angle is going to be 140 minus 0. Well, 140 minus 0 is 140. Or we can count the units along it, just like with a ruler. But we need to make sure that whatever side we start with, if I start over here, I'm going on the inside track because I'm starting at 0, because that's where 0 is. I'm not going to start with the outside track and start at 180 and go this direction. Yes? If the two spots aren't at whole numbers, if one of them's not at 0. No, if it's one side starts at 140 and the other goes over. So we want to know this angle here. And we don't have control of the protractor to adjust it to 0 one of the sides out. Now, types of angles. What would we say that this angle is? Yes, because its angle is between 0 and 90.
Wait, where are you at?
Just,
Oh, never mind.
okay, you're good. So an acute angle is between 0 and 90. Yep, right angle is exactly 90. This here would be and it's going to be between 90 and 180. And the last one they're going to call a straight angle or straight line. It's going to be exactly 180. Acute is between 0 and 90. Right is exactly 90. And obtuse is 90 to 180. And then a straight angle or a straight line is going to be 180 degrees. Now, the only way we can say an angle is a right angle is if we know it's exactly 90 degrees. This square has 4 right angles. Now, if we're given an angle, like this here,
We don't know this 93.
we don't. Let me get a... It is pretty close, but since it's not exactly straight up and down, it looks more like it's closer to 91 degrees. We can't exactly say. Because the difference between 90 and 91 degrees or 90 and 89 degrees is so small, it's actually hard to tell the difference.
But I know how to tell if it's a 93 angle.
Huh?
I know how to tell if it's a 93 angle.
How's that?
It has a box on it.
Yep. If there is a box drawn in for the angle, it is telling us that it is 90 degrees. Okay. Let's look at these here. So we're going to look at this one here. We want to measure the angle and then classify it. So our first one is GHK. Now, if we want to measure the angle, well, one of them does start at 0, yes? So I'd come over here, and 0 is on the inside track or the outside track?
Outside.
0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 125. And what kind of angle would this be?
That'd be obtuse.
Obtuse. Because obtuse is between 90 and 180. So we can use that protractor to figure it out. Any questions on this here?
Is it
Guys?
important to draw that?
No, I was just drawing it to give us an idea.
What talking about that circle or that?
Yes, that is degree. That is the degree marker. I won't necessarily count all for it, but it's good habit to put that up there. Let's look at the next one, JHL. JH.
It's that's right. So that's
Right? Yep. Because if we look at the protractor straight up and down, that is 90 on either one. If we go in either direction, that's straight up and down, that is 90. Any questions on these first two? So let's look at the last one for this set of 3. LHK. So this would be acute, because we can see it's definitely less than 90. Yes.
maybe 125.
So does either one of those rays start at 0?
I have a question.
Yes.
What do you answer? Just like minus it, like from 55 to 0.
So 55 is one of the spots, yes? So I can take it and subtract it from the other one, which is at, and we take the absolute value of it. Well, 55 minus 90 is negative. Well,
35.
the absolute value of 35, negative 35 is So that's what the subtraction was talking about earlier, where we can subtract the 2.
Would it be negative?
Now, there is another way we can do this. Because starting here, well, that is a distance of 5. And then from here we can go 10, 20,
30 plus 5, 50.
30 plus 5 will give it. Any other questions on this here? So we feel good with this? Let's look at 3 more. Okay.
We do want ourselves or by ourselves, not so we can get the right.
So number 4, I'm going to look at number 4. JHM would be,
35.
it would be obtuse. Now, since we started over here at 0, yes?
Yes.
10, 20, 30, 40, 50, 60, 70, 80, 90, 145.
Oh,
Guys, it started at JH, so start over here.
Would it, number 5, be 85?
So H, M, H, K. So we could do our subtraction like we saw in the other one, or we can count. Well, from here to here is 5, and then we have 10, 20, 30, 40, 50, 60, 70, 80. We're not quite there, and that's another 5 and 5 is, and 80 would make.
how did that get 145?
Because this here is either sitting at the 55 or 125 marker, and this one over here is sitting at the 145 or 35 marker. Because if we wanted to do the subtraction, we could do that too. We could say 125 minus 35. Absolute value of it would be the absolute value of 90, which is 90. So I would count, because it's a little bit easier to count than try to figure out which one it's talking about. Now let's look at the last one. MHL. MHL.
35.
Well, we do know it is going to be acute. So here, well, we have 5, 10, 20, 30, 40, 50, and these would add together to be, so it'd be 55 degrees. Huh? Count them? Yeah. Essentially, it's just a curved ruler, yeah. All we've got is a curved ruler. And a lot of the times, if we were actually measuring this with an actual angle, I would zero the angle out. I would put one of the zeros and then count that way. Yes? Questions on this here? In angles, we will use these little curved circles, these arcs, to show congruency. Like in our line segments where we talked about a segment bisector, if you notice each line, part of it had a little dash on it. That is signaling that the line segments are congruent. The equal number of segments show that those are equal. Now, if we look at this here, and it's a little bit hard to see on the printout, F has 2 and G has 1. Down here, D has 2 and B has 1. So what that is telling us that angle G is congruent to angle B, because any angles that have the same number of markings will be congruent to each other. They're printed in. Yeah, they're on the paper. The printer doesn't do a good job at getting that picture on there, and these even though the LED lights are covered up, it's still blur or kind of fading out the projector. Yes. Yep, so angle F would be congruent to angle D. So 2 would match up with 2, 3 with 3, 4 with 4, 5 with 5. So we can keep adding arcs or markers for a different set that are congruent. So with lines, we can add little dashes to show the different ones are congruent. And we'll see that coming throughout the semester. And it's kind of nice to know that those two are congruent or not. Now, it's told to us that angle ADC is 140 degrees. What's the measure of angle EFG going to be? What's EFG going to be? Quickly. So EFG would be what? 140, because EFG and ADC are congruent to each other. So they'll have the same angle measure. Any questions on this here? Okay. Okay, let's look at this next part, the angle addition postulate. I have a feeling I will show you. Let's go on and look at it. Don't write all this down because I don't think you need to. The angle addition postulate states, if P is in the interior of RST, then the measure of RST is equal to the sum of the measures of RSP and PST. Well, if I have an angle and point P in the middle, then sum, talking about addition, this angle here plus this angle here will add together to give me the whole. That's all it's saying. So if P is in the middle, then the whole angle is equal to its two parts added together. That's all this is saying. Just like the line addition postulate, if I have a line and a point in the middle, it's two segments added together to give me the whole. So unlike with our line segment addition postulate, where we started out with just numbers, let's look at this here. They told us that angle LKN, well, LKN is the whole angle, isn't it? What is it? 145. Now they told us LKM is 2x plus 10, and angle MKN is 4x minus 3. Well, from our postulate we just had, they told us that LKN is equal to the sum of its two parts. LKN plus the measure of angle MKN. So really we're saying that the whole angle is equal to the two parts. Well, let's make this a little bit simpler. LKN is what? 145. What is LKM? LKM is 2x plus the other angle is? We're really saying 2x plus 10 and 4x minus 3 added together will give us 145. Now, if I want to find either measure, really, if I find the value of x and plug it back in, it'll tell me its angle measure. Well, let's combine like terms. Well, 2x and are like terms. Well, 2x plus 4x is 6x. 10 and 3 are like terms. 10 minus 3 is? What do we need to do next in solving for the value of x? I would subtract 7 from both sides. Because when we look at this here, we wanted to first get variables on the same side. Well, x is already all on one side, yes? So let's get rid of the 7. Because if I subtract 7 from both sides, this side here I will get 6x. 145 minus 7 is 138.
Hannah Marie Sherman come to the office. Anna Marie Sherman come to the office.
For the most part, we can do some of the individual steps. We can't type the whole thing in all at once.
Do I have to write all the letters down?
In a minute. So you don't have to write all the letters. I write that out just really to explain the formula that we had, the postulate. The whole angle is equal to its 2 parts. Now, it was asking for the measure of each angle, yes? So this here is 2x plus 10. Well, what is x? So I can say that its angle measure is 2 times 23 plus 10. Well, that's all numbers, isn't it? No variables, 2 times 23 plus 10? We can type that in. Well, 2 times 23 is 46, and 46 plus 10 is? So the measure of this angle here, the measure of angle LKM is 56. Guys. We're almost done with this problem. Now the other angle is 4 times x. Well, x is 23 minus 3. So we could type this in 4 times 23 minus 3. Well, 4 times 23 is 92, and 92 minus 3 is 89, guys. So the measure of the other angle, measure of angle MKN is 89. Well, what is 56 plus 89?
40,
What is
45. 145.
One-
Or 145, yeah.
well, what did it tell us the whole angle was?
Oh, duh.
So those two angles should add together to be equal to the total. So when we're doing these here, we can add the answers that we get for the measure of each angle back to each other to see if we do get back to the whole. Any questions on this here? Okay, we'll stop here for